All right, 6.4, we're going to talk about the fundamental theorem of calculus. So fundamental theorem of calculus involves our integral. It says if a function f is continuous on the closed interval from a to b and capital F is an antiderivative of f on the interval from a to b, then we can find our integral from a to b by taking the antiderivative of b and subtracting it from the antiderivative of a. Subtracting the antiderivative of a from it. So this is like a shortcut to what we were doing yesterday. So instead of using the limit process, we can take the antiderivative, so it involves our antiderivatives that we did in the last chapter, and we can plug in b and a and subtract them. So here are guidelines for using the fundamental theorem of calculus. It says, provided you can find an antiderivative of f, you have a way to evaluate a definite integral without having to use the limit sum. So we were using the limit sum before. Now we can only use this if it is possible for us to find the antiderivative. So if there was some terms where we don't know the antiderivative for, we could always use the limit process. So in applying the fundamental theorem of calculus, the following notation is convenient. So we'll take the antiderivative first. It helps if you put this little bracket on it, and then we just plug in b and subtract a. So we'll practice some of these. It says down here, it's not necessary to include a constant of integration c in the antiderivative because when you subtract c, it ends up just canceling itself out. So when we take the antiderivative, you don't have to put the c there. So let's look at example 1. So we are going to evaluate each definite integral. So here let's take our antiderivative first. What's the antiderivative of x squared? Awesome. I'm going to call it 1/3 times x cubed, but same thing. And what's our antiderivative of -3? -3x. Perfect. Then I'm going to put this little bracket here to help me remember that I'm evaluating from 1 to 2. So we always start with the b. We're going to plug in 2 first. So I have 1/3 times 2 cubed minus 3 times 2. And then minus, now I'm going to plug in 1. So 1/3 times 1 cubed minus 3 times 1. So this here is our f of b. And then this part here is our f of a. We always subtract b minus a. So when we evaluate here, 2 cubed would be 8/3 minus 6 minus, I'm going to do inside the parentheses first. Just be careful with the signs. 1 cubed would be 1 times 1/3 is just 1/3, and then minus 3. If you want to, find your f of b, so continue to solve the ones in the blue first, and then subtract it from your f of a. We can combine those together. Just because it has fractions here, I think it might be easier. I'm going to distribute the negative, but just be super careful with the signs and with the math. That's where this question can go wrong, is if we're not careful with the signs. So I'm going to call this 8/3 minus 6 minus 1/3 plus 3 now. I'm just going to add my whole numbers together and then my fractions together. So this would be 7/3 minus 3. And then I just need a common denominator, so I can make this 9/3. 7 minus 9 would be -2/3. So this would be our answer. Now, if this question asked me for the area under the curve of x squared minus 3 from 1 to 2, my area would be negative 2/3. So this is a shortcut for finding our area under the curve as well. Any questions here? Let's do it again. So let's look at B. So first thing we want to do is find our antiderivative. I'm going to call this 3 times x to the 1/2 power. Let's rewrite it so we can find our antiderivative a little bit easier. When we find our antiderivative, we add 1 to the exponent. So this would be x to the 3/2 power. And then we divide by 3/2, or we multiply by 2/3. So the 3's cancel, so then this ends up being 2 times x to the 3/2 power. Which number would I plug in first here? 4, awesome. Let's find 2 times 4 to the 3/2 power minus, then we'll plug in 1, so 2 times 1 to the 3/2 power. So always plug in your B first. 4 to the 3/2 power. This is like saying the square root of 4 cubed. What's the square root of 4? 2. And 2 cubed? And 8 times 2? 16. Perfect. Minus, what's 1 to the 3/2 power? Just 1. And 1 times 2 is 2. So this would be 14. So example 2 is a little bit different because we have an absolute value. We haven't really talked about how to find our antiderivative of an absolute value, but when we're evaluating our definite integral, we need to follow a couple steps before we can take our antiderivative here. So what we're going to do is we're going to split it up into 2 parts. We're going to find the negative part of our function and the positive part. So in order to do that, we want to find where this equals 0 first. That's going to tell us where we'll split it up. So step 1 is find what makes the absolute value equal 0. So 2x minus 1 equals 0. What would x equal? Perfect, 1/2. So 1/2 is where we're going to split this up. So I'm going to take the antiderivative from 0 to 1/2 and the antiderivative from 1/2 to 2 now. So I have to split this up into 2. And when we split up our function, we need to split it up into a negative and a positive. So I'm going to write it on the side over here. We have our function, but I'm now turning it into 2 parts. So I'm going to kind of write it as like a piecewise over here. If I have 2x minus 1, where x is less than 1/2, and 2x minus 1, where x is greater than 1/2. Let's say I plugged in 0 here into my function. 2x minus 1, or 0 minus 1, would make this -1, but what do the absolute values do to it? It makes it positive. So it changes the sign. So where my values, I have to change the sign. So when my function here ends up being negative, which is when it's less than 1/2, the sign changes. So I'm going to multiply this part of my function by a negative. So half of your function's going to be multiplied by a negative, the other half stays the same. If I plugged in a number greater than 1/2, let's say I plugged in 1, 1 times 2 would be 2, minus 1 would be 1. The absolute value, nothing happens to it. So I don't have to change anything to that part of my function. It's just where your sign changes, so the negative part of it. So that's why we find where it equals 0. Because the negative part, we want to multiply by a negative. The positive part, we leave it the same. So my function here from 0 to 1/2 is going to be negative 2x minus 1. And then from 1/2 to 2, this stays the same. So this is 2x minus 1. We're just adding these two together. So anytime we have an absolute value, you want to find what makes it equal 0, split it up. One part's going to be negative, the other part has to stay positive. But it does matter which one you turn negative, so make sure you just double check. Plug in a value and see where does the sign change. That's the one that you make it negative. So here, before I find my antiderivative, I want to distribute the negative. So I have negative 2x plus 1. Now I can find my antiderivative here. So we're going to treat this as if it's like two separate problems now. I'm just going to find my antiderivative from 0 to 1/2 first. And we'll find a value for this, and then we'll add it to the other answer. So here, when we take our antiderivative, what would our antiderivative of negative 2x be? Awesome. Negative 2x squared over 2, which would just be negative x squared. And then plus, what's the antiderivative of 1? X. Awesome. And then we're finding this from 0 to 1/2. What would I have to plug in first? Plug in 1/2 first. So negative 1/2 squared plus 1/2 minus, then we would plug in 0. So negative 0 squared plus 0. So 1/2 squared would be 1/4 times a negative would be negative 1/4 plus 1/2. Let's give it a common denominator so we can make this 2 over 4. So this would end up being 1/4 minus 0, which would just be 1/4. So this is our first part, our first half of it. We're going to need to do the same thing for the second half. Perfect. Let's do the other half. We're taking our antiderivative of 2x minus 1 here. So our antiderivative of 2x would be just x squared minus x from 1/2 to 2. What would I have to plug in first here? Plug in 2. So we have 2 squared minus 2, then minus, when we plug in 1/2, we have 1/2 squared minus 1/2. So here we have 4 minus 2 would be 2, minus, inside of our parentheses here, this would be 1/4, minus, I'm going to give it a common denominator, so call it 2 over 4. So this ends up being negative 1/4. So 2 minus negative 1/4, this turns into a plus, and we'll give this a common denominator 2. So I'll call this 8 over 4. So this turns into 9 over 4. Any questions on how we got that? Awesome. Then we just add these two together. We get 10 over 4, which would simplify to what? 5 over 2. So when you have an absolute value, you have to split it in half. One more thing that I just want to mention here. When we start, we find what makes the absolute value 0. But if what makes the absolute value equal 0 is not in our interval, so if it's not from 0 to 2, let's say like 10 made this equal 0 and it wasn't from 0 to 2, you wouldn't need to split it in half. You would just want to make sure that what is in your interval isn't what affects the sign in the absolute value. So you wouldn't have to split it, but you would want to still check and see if it's the part that you have to multiply by a negative or if it's the part that you leave it alone. For example 3, we want to find the area of the region bounded by the graph, the x-axis, and the vertical lines x equals 0 and x equals 2. So we're finding the area under our curve here. Our function is 2x squared minus 3x plus 2. And it is between the intervals of 0 and 2. You could use the limit process here if you wanted to, but now that we know our shortcut, we could just find our antiderivative. So 2x squared would be 2x cubed over 3 minus 3x would be 3x squared over 2, and then plus 2x. We're finding our integral from 0 to 2. What would I have to plug in first here? Got to plug in 2 first. So 2/3 times 2 cubed minus 3/2 times 2 squared plus 2 times 2. If you want to simplify this part, get an answer first, then subtract it from your other answer. You could break it up and do it in 2 parts. Whatever is easier for you to do the math. I'm just going to do it all together. So minus, we would plug in 0 next. So here we get 2/3 times 0 cubed minus 3/2 times 0 squared plus 2 times 0. What do we see that this is going to be? 0. Because everything gets multiplied by 0. So this is just 0. So we really just have to do the math with our left side here. 2 cubed would be 8. So this turns into 16 over 3. 2 squared would be 4 times 3 would be 12. And 12 over 2 would be just 6, so minus 6 plus 4. So this would be 16 over 3 minus 2. Let's give it a common denominator. We can make it 6 over 3. And then this turns into 10 over 3. So that would be our area under the curve. Right, so the mean value theorem for integrals states that somewhere between the inscribed and circumscribed rectangles, there is a rectangle whose area is precisely equal to the area of the region under the curve. So it'll tell us on the next page, but we'll have our mean value rectangle, which would be f of c. So c is some value or some height here that gives us that perfect rectangle that's not an over approximation or an under approximation. And then if we multiply that times b minus a, so times the width, that would give us our area. So here's our mean value theorem. If we find f of c, multiply that times b minus a, it'll equal our integral. So the value of f of c given in the mean value theorem for integrals is called the average value of f on the integral from a to b. So this is our definition for the average value. This is f of c. So f of c is equal to 1 over b minus a times the integral of f of x. So this is our average value. If the question asks for just the average value, we would use this formula where we multiply the integral times 1 over b minus a. So in example 4, we want to find the average value of f of x on the interval from 1 to 4. So our average value is the formula where we have to multiply that 1 over b minus a times our integral. So this is our a and our b. So we're finding 1 over 4 minus 1 times the integral from 1 to 4 of 3x squared minus 2x dx. Different ways that you can do this here if you want to simplify the fraction out front and just keep in mind that you're going to multiply your answer by 1/3. You can do it that way. I'm going to kind of do both steps at the same time. So next I'm going to take our integral. So when I add 1 to my exponent and divide by 3, we get x cubed. And then when I add 1 to my other exponent, it would be x squared. So minus x squared. And then we're finding this from 1 to 4. What would I have to plug in first? The 4. So 4 cubed minus 4 squared. And then minus, when I plug in the 1, this would be 1 cubed minus 1 squared. 4 cubed is 64. Minus 4 squared would be 16. And this would be minus 1 minus 1. What's 1 minus 1? 0. So this would be 0. So then we just have 64 minus 16, which would be 48. So our area under the curve is 48, but to find our average value, we have to multiply that times 1/3. So 48 divided by 3 would be 16. So 16 is our average value. So 16 is our f of c. We're going to take this one step further. Let's say that this question asks us to find c. So if f of c equals 16, how do you think we could find what c is? We're not plugging it in. So we would set x cubed minus 2x, 3x cubed minus 2x squared, we'd set it equal to 16. Because this is f of x, if I found f of c, we could just plug c into the x's, but we're just looking for that value. So whether you wanted to call it x or c, it doesn't matter. I like to leave it as x's, but we're finding what value makes this equal to 16. So 3x squared minus 2x equals 16. How would I solve this? Why can I not take out an x? Because we have 16 on the other side. If we were going to take out a GCF, we would need it to be equal to 0. So let's move the 16 to the other side. We have 3x squared minus 2x minus 16 equals 0. Now that it's equal to 0, I could factor. To factor here, we can multiply our first times the last. So 3 times negative 16 would be negative 48. What are two factors of negative 48 that add to negative 2? Awesome. Negative 8 and 6. So we have x minus 8 and x plus 6. We can't forget, if we start by multiplying the first times last, we have to remember to divide by that first number. So I'm going to divide both of these by 3. So we get 3x minus 8 and x plus 2. So x is equal to 8 over 3, and x is equal to -2. So these are two values to make our function equal 16, or two values of c. But are both of these in our interval that we're talking about? Are both of these from 1 to 4? Which one is not from 1 to 4? -2 is not from 1 to 4. So our only value of c would be 8 over 3.